Okay. All right. So you got your packet, and what I'm going to do is we're going to go through a little. Oh, before we go too far with this, I was talking to Mr. Hawk, and there was kind of a discussion about this thing called negative exponents. Now, if you remember yesterday, if I'll tell you what, let me just put this off to the side for a second, and if I take something like x to the fifth over x to the 3. What is the outcome of that?
X minus 2.
Careful.
To
Okay, there's, the question is who wins and by how much, and it's going to be top wins by 2. So I have x 2 over 1, right? So what is this though? If I reverse it, I get x to the third. Oh, and of course, what is that equal to? That's equal to x 5 minus 3. So we can subtract the bottom exponent from the top exponent. That becomes a rule of exponents. So what if I reverse this and I have x to the third over x to the fifth? If I subtract the exponents, I'm going to get what? X to the 3 minus 5, which equals x to the negative 2. Well, what is x to the negative 2 really equal to?
1.
Okay, go ahead, say it.
1 over x.
All right. So I just want to review what we talked about yesterday was that if there is a negative exponent, what that means is that we can make it positive by moving it to the other side of the fraction bar. Is that okay?
Yep.
All right. So we did that we actually did that the other day, and I just want to make sure that that's still somehow stuck in us, all right? So let me go ahead and erase this, and we'll get started. So first thing we're going to do is we're going to talk about what's called fractional exponents. And come on, you. And what I want you to do is actually, if you don't have I guess the point is if you don't have a calculator, you can. You don't need a calculator right now anyway. But actually, you do need a calculator right now. What we're going to do right now is we're going to be dealing with these kinds of expressions. What we're asking you to verify is that the square root of 9 is equal to 9 to the 1/2 power. So how do you put that in your calculator? You're going to put that as 9. And then you use this little up arrow button, and you're going to put 1 divided by 2. All right? So, Lauren, you really so don't want to sit this close to me. You won't use your calculator. Oh, yeah? Okay. Then you work with Maddie, and can you two work together? Abby and Kenza. And Hunter, can you, actually, if you guys, want to work, just make sure you guys can support each other, all right? So just, again, just fill in these, do A, B, C, D, E, and F. I have a question. Does everyone know how to do the third root of 8 on a calculator? You don't?
How do you put the first letter C in your calculator?
Okay, what's that?
How do you put C in your calculator? Like the first part of it?
How do you put... I'm sorry, which number are you on? You're on C? You don't... Oh, I thought you were trying to find the letter C. Okay, so what you're going to do for C is, let me just tell you, if you go to... to be able to do C, what you need to do is on your calculator, left-hand column, 3 down, you're going to push the math button. And on the math button, if you select number 4, it gives you cube root. You see that?
Yeah.
Now, what if what's going to happen when you get to E? E is the fourth root. So what you're going to do for that one is you're going to select the number 5 for the fourth root.
What button do you use?
Push math.
Yeah.
Let's do E. Let's do E, all right? You want the fourth root of 16. So go to your calculator and press math, which is the third button down on the left. And then you're going to pick the number 5. You'll put the 16 in. Let me see what's going to happen here. Oh, no, I'm sorry. Clear. Put in the number 4. Then go to math. Press the number 5. There it is. Did you do that? So for E, you're going to press 4. Press the number 4. And then you press math. And select 5. Option 5, and then it will just show up as fourth root. Then you just put the 16 inside.
So for C, would we have to put 3 and then a math button?
You can do that too. Yes, you can do it that way too.
For any number.
But there is also a cube root function in math also. So you have a choice. But the idea at the end, guys, is just to verify that these things are true, all right? How are we doing so far? Okay, I'm going to pause the video for now. Till everyone gets their answers. Any variations on what's going on here? Anyone? So what is this saying? What is this telling us about fractional roots? All right. So based on what we just talked about, or based on what you just saw, what is an equivalent expression to the let's say the 7th root of 29? How can I rewrite that? 29 to the 1/7. Okay?
Wait, 29 or 2?
29. All right? Is everyone okay with that? Okay, so the idea here is just to give you experience working with using fractional exponents as opposed to radicals only, okay? Any questions on that, Kenza? All right? And tell me though, Abby, I was right, wasn't I? That was a very convenient. Okay, sorry about that. All right. Anyway, am I mean to make you put your phone away? You look at me like I'm like you're scowling at me. Okay, good. Sorry, just want to make sure. Anyway, let's go. Let's move to the next exploration. Ready? So each one of these things is going to kind of lead us up to where we're going to go. It's going to lead us up to where we're going here. So next, us about how we can rewrite radical exponents. Okay, got it. Thanks for asking. And Kenza?
I got it.
Okay, you got it. Good. Is exploration 2. Right here, this is where you're going to be using your calculator again. But in this case, what's going on is, let's look at A. What I want to do is, what we're going to do is we're going to we're going to rewrite this to get rid of the radical. Okay, so watch carefully. What is another way to write square root of 5? You guys just learned it.
1 over 1 to the
Well, to the 1/2, right?
Why 1?
To the 1/2, to the 3. Okay? So I rewrote the exponent square root of 5 as 5 to the 1/2. Any complaints with that?
Yeah, I thought cube was gonna be
Why or how?
1/3.
Why?
Okay, let's get back to the instructions. It says, use the definition. It says writing expressions in rational exponent form. So they're asking us to go from radical form to exponent form.
But why 1/2 out of any other fraction?
Okay, can anyone explain why it's 5 to the 1/2?
Is it square? Because it's just 1 square root.
exploration 1, right? We just did showed us that the square root of 5 is equal to.
Wouldn't the next one be 4 to the 1/4 power?
Is this what you did? You remember? Turn the page, right? Right. What? If you turn the page and you look at the previous page, is everyone seeing what that's? So let's go ahead back. So I can rewrite. So we're okay. I can rewrite the 5 square root of 5 to square root and make it 1/2, right? Now, when I have an exponent to an exponent, what do I do? What do I do to the 1/2 and the 3? I can.
It would be, for example, for you, it would be 4 to the power of 1/4.
Wait. I'm going to say 3 times 1/2 is 3/2, right?
Oh, you're okay.
Okay, so we have a new weird-looking expression here. We have 5 to the 3/2, which means what? It means the 2 means square root, and the 3 means to the 3rd power. Okay, so these are fractional exponents that you may have never seen before in your whole life. Can you put that in a calculator? Can you go 5 caret or arrow up 3 divided by 2? Absolutely. All right. Did anyone do it? Comes out to something weird? Okay. So what I'd like you guys to do right now is to take a moment and use this idea. What I'd like you to do, you don't have to put it in a calculator. What I'd like you to do is to be able to transform the radical, right? The radical expression into just a number with an exponent. Okay? So I'm going to do B, and then I'm going to pause, and then you're going to finish the rest of these, all right? So I'm going to go B is 4 to the 1/4 power squared, which equals 4 to the 2/4, which is 4 to the 1/2, which is really the square root of 2, isn't it? 4, right? So what does that equal?
2.
It just equals 2 at the end, right? Weird, huh? Okay, I'm going to pause it while you guys.
So when you're multiplying the exponents, it's just multiplying the numerator.
Right, it's basically, think of it as, in this case, it would be 1/4 times 2 over 1, right? So you got 1/4 times 2 over 1. Remember, we just multiplied the numerators to get the 2, multiply the denominators to get the 4. Does that make sense, Abby?
Yeah.
Okay. So, all right, I'll pause it, and then when we come back, we will check out the answers. Okay, so these are the bases to the exponents, right? All right.
Number E.
Letter E. So square root of 15 to the 3rd power, right? So, it might be worth remembering that, this is the same as, even though they don't write it, that's a 2 in there, right?
I treat it like a 1.
Okay. So it's a 2, but because we use square roots so often, they just don't do that. So one thing that's worth noting is, is what is the denominator of these fractional exponents? What's the denominator?
The same number as.
That's the root, right? That's the root. And that's like the power that you're bringing it to, right? The 2. So based on that, here, I have a question for you. What would be, see if you can figure, oops, how did I do that? See if you can figure this one out. 25 to the, I'm going to say 3/2 power. So take a moment. That looks really weird. But let's do the 2 in the denominator. What does the 2 in the denominator mean, Tristan? Means 5, right? So this means square root. Which one we do first doesn't matter. So I'll take the square root of 25 first, and I get what?
5.
5, but I still have the 3 there. And then 5 times 5 is 25 times 5 is
125.
125. All right?
Mr. Shutter,
Yes, sir.
why is C 3 and not 9?
Yeah, that's what I was just.
Why is C...
Nine.
Oh, sorry, I have no idea. Thank you very much. Okay, that's correct. Thank you very much. Okay, and then, yes, thank you. Okay,
Keep the 9, right? You don't take the.
so it's 9 to the 2/3.
Yeah, but so you don't take the square.
No, because the 2 is on the top, not on the bottom. This we'd have to take the third root. You know, in other words, would number by itself 3 times is 9. Well, that's not a number. We can do that in our calculator, but it's not one that has a nice whole number value. Okay, so let's move. Are you guys okay so far? Right? All new stuff here, I know, but it's pretty cool. Okay, so in this one right here, what they want you to do is do the reverse of what we just did. Okay? So on this one, what they're asking you to do is to return this to the form that you started with in the previous exploration. So in this one, what we want to do is put it back in radical form. So what is the 3 on the bottom going to do to the 8? Well, I'm just going to do it. I'll tell you what. Let me just do it and see what you guys see if you agree with me. I'm going to rewrite this as the cube root of 8 squared. And see if you can agree with that.
I do.
You do. Do you know cube root of 8 has an actual answer? There is a number multiplied by itself 3 times, it equals 8. So we can actually simplify that, couldn't we? That's going to be the same as 2 squared. Or 4, right? Okay, let's the next one. Let's see if we can rewrite the next one. So what's the radical for this one, Abby? On B?
Yeah,
No, I'm saying if you look at the 2 in the bottom, right, on the denominator of the exponent, what does that mean? That means square root, right? So it means square root. So the 2 on the bottom means square root, right?
It's going to be squared.
And then it's going to be to the 5th power. So the denominator tells us the root, right? For instance, number 12. 12 to the, what's going to be the number inside? It's going to be 4, right? And then the outside is going to be the top number, right? I'm going to pause and challenge you guys to do the next 3, okay? Okay, so here are the answers. Say it again.
Is there a chance we put the 2 in for D&D?
You've never did that in your life, have you? I mean, haven't that always been square root? If it floats here, it's fine. Go ahead, put it in. All right, that's fine. And okay, so yes, ma'am.
Why can you simplify E to 4 to the 3rd?
Correct. Which is 60 something, 64, right? Okay. Well, what you've just done is what we're gonna what I'd like you guys to do here, and then we'll take a break. If you guys go to the bottom, all right, of that same page, what I want you to do is to use your newfound knowledge to rewrite each one of these as a regular number. All right? So none of them will be decimals, actually. They're all going to be whole numbers. So, Abby. Okay. So look at let's look at A, right? Let's do the root first. So it's going to be, what does the 2 on the bottom do?
It's
Square root of 4
2.
to the third power. Can we do that?
What about for B?
That's going to be
It would be root of 5.
that's going to be 2 to the third, which equals 8. B,
2.
fifth root of 32 is actually 2.
I don't know that.
Oh.
Wait, what?
The fifth root of 32
2, right?
is 2. Right.
For real? So then it can just be 2 to the 5th.
And now it's going to be 2 to the fourth power.
4.
Right?
Oh,
Yeah.
So the fifth root of 32 is equal to 2. And now we still have the 4 up there. 16. Okay?
How did you do that one?
The fourth root of 625. Does anyone know that 625 is 25 times 25?
How did you do B?
Okay, so B is the same thing as the fifth root of 32 to the fourth power. It just happens that 2 to the fifth power, or 2 times 2 times 2 times 2 times 2, is 32.
Not 2.
32 is 2 to the fifth power.
No.
So the fifth root of 32 is just 2. If you multiply 2 5 times, you'll get 32. But you still have the 4 on the top that we have to, right? So the fifth root of 32 becomes 2, but we still have to multiply the 2 now by 4 times. 2 times 2 times 2 times 2 for this to get the 16. Is that good? All right.
As a 2 to the 4th power, we just do that's the answer. So the answer is 16.
2 to the fourth power is 16, correct? 2 to the 4/5 power. I'm sorry, yes. 2 to the fourth power is 16, correct.
And that's the answer.
And that's it. Okay, now with the 625, you may or may not remember that 625 is the same thing as 25 times 25. Does anyone know that? Well, you know it now. And 25 is 5 times 5 and 5 times 5. So 625,
The last one is this
5 to the 4.
yeah.
5.
So what does that mean about the fourth root of 625?
5.
It's 5.
Shy.
Yes?
The last one's gonna be a decimal.
Well, not if you reduce 6/3.
Oh, can you do that?
Yes, you can. Okay? I know this stuff is like tugging at you a little bit, but you'll get used to it. It's pretty cool. So, yeah, F looks kind of tricky. I'm going to pause and see if you guys can figure some of these out. And but on F, you'll need to be able to reduce the 6/3 into what? 2. Right? So this is basically going to be 100 squared, which is a 1 followed by 4 zeros. Okay, I'll pause. See if you can do D and E. So these are your answers. D, right? Square root of 49. You got square root of 49 to the third power, which is 7 to the third. With E, you got the cube root of 125, which is 5. To the fourth power is 625. And similar to C, correct? With F, again, 6 over 3 is the same as 2. Guys, you need to take a break. And so, can you guys break for, I'm going to give you 7 minutes because that was a lot. All right? And hopefully at this point we can, if you are okay with this, if you're not, please stay and ask a couple more questions of me. But if you're okay with what we just did, we should be able to move pretty quickly through the rest of this. All right? Nice job. Take a break. Please stand up. Don't sit down too long. Okay, break's over, and let's move to our next page. So, okay. All right. Before I get into number A and B, I want to talk about something that we've actually seen before. I want to get rid of this. All right. Something that we've hinted at before. You good? Okie dokie. All right. So one of the things that we found out, we figured out a long time ago, is that if we take the square root of a negative number, there's no real square root to this. In other words, there's no two numbers which multiplied by themselves gives us a negative number. And this is when we got into imaginary numbers. But in this section, we're not going to be talking about imaginary numbers. Basically, when we take the square root of a number that's negative, or even the fourth root of a negative number, let me give you an example, like negative 32. Now, 32 to the fourth power of 32 is 2. 16, sorry about that. Oh, let's try that one more time. Negative 16, right? Okay, there we go. Negative 16. The fourth root of negative 16 can't be done either. So any square roots or even roots of negative numbers will not produce real answers. Are we okay with that? So square roots are even rooted. If the root is even, and we cannot take the even root of a negative number. But watch this. What happens when we take something like the cube root of negative 8? Does it have a real answer?
Yep.
What is it?
Imaginary.
Negative 2, actually. Because negative 2 times negative 2, think of it. Negative 2 times negative 2 times negative 2, what does that equal? Negative 8. So it's true that the cube root of negative 8 is equal to negative 2. So we can take the odd root of a number and get a real value. So negative values in odd radicals are okay. Here's another one. The fifth root of negative 32. It is negative 2. We can do that one. All right? So it's what we're going to be doing here is, now that we're dealing with bigger like roots, 2, 3, 4, 5, we need to recognize that we can take the odd root of a number. The third root, the fifth root, the seventh root. We can take the odd root of a negative number. Can we take the even root of an even number? Of a negative number? Can we take the even root, a 2, of a negative number? And the answer is no. Okay? So we cannot take an even root of a negative. Go ahead. Who's saying Mr. Shy? Someone out there? But we can take what? The odd root of a negative number. All right. So now I need to just shrink all that, though I don't know if I can. So now what I want to do is let's go ahead to here. And with loaded with that information, did anyone like space out when I talked about that? Kind of. Damn. Well, okay. Well, let's take a look at this. It says find the indicated nth root of the value a. In other words, take the third root of negative 216. First of all, can this be done? Yeah, you can do this on your calculator without getting an error. Does anyone know that there is a number that multiplied by itself 3 times is actually 216? Go ahead and try it on your calculator. Figure it out. Is it 9?
I don't know.
I don't think so.
What's another number?
Go ahead, do it in your calculator. Use the math function. Use the math function. What is it? It's -6.
Yeah, that's not.
Not bad, huh?
Yeah.
So we can do that because we can take the odd root. Odd root is a 3, right? We can take the odd root of a negative number. Will B work for us?
No.
It's not going to come out even, right? But what would be the oh, let's go ahead.
Oh, yeah, it's 3.
It is 3, you're right. So the fourth root of 81 is going to be equal to 3. All right? Now what I'd like you to do is go to those questions 1 through 4. And let's go ahead and look at number 2 first because there's a problem here. And what is it?
Can't be.
Right. There's no real root, right? If you remember that this could be an imaginary, could be 7i, plus or minus 7i, but in this case, in this chapter, we're dealing only with real roots. So there's no real answer for this. I mean, real number answer. So no real answer. Or solution, I guess is the word. It's imaginary, but that's not real. Because why? It's imaginary. Got it?
Why do imaginary numbers exist?
So we're not going to do imaginary numbers right now. We're talking only about real roots. Okay? So if you guys can go ahead, what I'd like you to do is find the answers to 1, 3, and 4. I'm going to pause this now and... All right.
Have calculators on the quizzes for...
If you need it, yes, but the question is, can I produce questions that test this that don't require a calculator? For instance, like number 1, right?
Yeah.
So for number 1, we're looking at the fourth root of 16. At this point, it's probably becoming clear that that's going to be 2. All right. Again, number 2, there's a violation. It's an even root. We cannot take the even root of a negative number. Okay, we can only take the what root of a negative number? Odd. So we can do number 3, right?
Yeah.
What number multiplied by itself? Right. And again, it's cube root of negative 125, and that's going to be equal to negative 5. Excellent. And then, surprise, surprise, right, the fifth root of 243 is, okay, is 3 though. Okay, excellent. Let's move up. So what we have right now, guys, we're just going to move up 2 more steps, but it's all kind of related. How are we doing so far? Because what number multiplied by itself is negative 49? What's that? There are no numbers that multiplied by themselves because any number you multiply by itself becomes a positive, right?
If number 2 was 49 instead of negative,
That was 7.
Correct.
then it would be 7.
It would be 7, correct. But this is where we used to get into the imaginary numbers, right? Is with this stuff. But again, we want to distinguish between 2 things: the imaginary numbers and the real numbers. And in this particular case, we're dealing with the real nth root, right? So the real number nth root. Again, real numbers are defined as any number that you can find on the number line, and imaginary numbers are they're in a whole different category of complex numbers, which we're going to stay away from complex numbers and focus only on real solutions, real number solutions. Okay, so that's a great question. The answer would have been a couple chapters ago, as it would have been 7i, right, which is an imaginary number. But we're going to say we're not going to we're not interested in the imaginary solutions. We only are interested right now in real solutions. Is that good? Let's move to the next page. And on this next page, it says evaluate these expressions. So this comes from the exploration that we've already done. All right. So let's go ahead and see if we can figure out A. A should still be in our heads. Okay. And how did you get that, Kenza? Square root of 16 to the third power, which is 4 to the third, which is 64. Very good. Now the next one's got a negative exponent, all right? So before we do that, let's do the fifth root of 32. Can we do that? It's 2, right? So we're going to go fifth root of 32 to the negative 3 power. So this is going to be the same as 2 to the negative 3. Now the question is, what do we do with that god-awful negative number? No.
It's 1
Over
the third.
2. Thank you. That's the same as 1 over 2 to the third. If you remember, it depends, and if they oftentimes they'll ask you to write the answer as a positive exponent. I would rather you didn't, because what is this actually equal to? 1/8, right? So let's recall again that a negative exponent is telling us that we can make it positive if we move it where? To the other side of the fraction bar. Okay? So let's go ahead and this is going to be a real impress me by seeing if you guys can figure out 5, 6, 7, and 8. All right? Quick question though. What is the 8th root of 1? What's the square root of 1? 3rd root of 1? 20th root of 1? Okay, that might help you with 8.
What if it's negative?
So it's just 1.
If it's negative 1, ooh, got to be careful there.
No, I mean like
For
for number 6.
number 6? Okay, so let's I'll do 6 with you and then I'll pause, all right? So let's rewrite this in radical form. It's going to be the square root of 9, right, to the negative 1. So do one step at a time. Okay? So what does that give us? It gives us 3 to the negative 1. So think about that. To make that 3 to the positive 1, where do I have to move it? To the other side of the fraction bar, right? So I need to move it to the bottom. Now 3 to the 1 is just 3. So the final answer is just going to be 1/3. Did you get that one?
Wait, are we like supposed to know like 4 through 81? Like, are we supposed to know that?
I'm lost. 4 through what?
Like, are we supposed to know these in our head? No, right?
You will get to know. You'll become more familiar as we do more of them. So the idea that you would know that 2 to the 5th is 32, I think is probably new for us, right? The idea that 25 squared is 625, but as we move through this section, you're going to see these numbers over and over and over again. You're going to see numbers like 16, 8, 27. What's 27? 3 to the third, right? So we could maybe take a moment at some point and write down all the numbers that we're going to see a million times, but I think, Abby, you're going to just get used to seeing them. All right? Okay, so I'm going to pause for a minute while you guys finish this. I guess I was going to pause you, but I didn't pause. Okay, so 8, 10, 9, 10, 11, 12. Use your calculators to evaluate these values, rounding to the nearest tenth. So these are the answers, and remember that we can either use the fractional exponent all by itself, or we can use the math function to do numbers 11 and 12. We can just put in the cube root, whatever. So there's at least two ways we can do these. How many people did them all kind of fractional exponents like that?
Mm-hmm.
Did anyone use the math function to do?
Oh,
Okay, cool. It's even split. All right.
Why do I keep doing
Which one?
like all
Make sure you put them in parentheses, the fractions. So for 64, you want to write 64 and then that little up arrow and then -2 divided by the 3 in the parentheses. Is that working better? Okay. So, are you guys ready for final round? If we can move through this, I got a feeling that we're actually going to, maybe I'm going to get you out a little bit early, all right? So now we have this amazing way to solve equations that we never could do prior to today, okay? So watch. So here's a problem that you've never been able to solve in your whole life. Am I right? You ever solved that before? Okay.
Just divide 4 by yourself.
Okay, I'm going to start with that. I'm going to divide both sides by 4. And I'm going to get, I end up with 32.
So that's
X to the 5th equals 32. Now, you're right. But I want to see it. I want to think about it a different way. Can I show you something? All right. So one of the ways that I can solve this is I want to get X by itself. Now, one of the ways to get X by itself is to multiply the 5 times 1/5. Does anyone know what 5 times 1/5 is?
1.
It is 1. If I do the left side, I also have to do the right side. All right? So can you see what's going on? Now I get X equals the 5th root of 32. Did you see how I did that though? Okay? So Kenza was right. She just looked at it and she goes, 2. But, sometimes they're not going to come out nice and neat like that. But what I'm doing is basically, in essence, what you did, Kenza, was took the 5th root of both sides.
Oh, I know. I just memorized it.
And then she okay, but anyway. Does everyone recognize? So I do want you to get an idea of the following. If I have something like x plus 3 to the 1/4 power, what power can I take that to get rid of the 1/4? 4, right? So if you didn't understand that, let's go ahead and do another problem. Ready? Let's go. Let's do this one here. I got x minus 3 to the 4th equals 21. Now, what do I have to do to get the x minus 3 to the 4th to the 1 power?
We'll get rid of the brackets first.
I can bring the 1/4 power, the 4th power to the what power?
Do you have to?
To 1.
Yeah, no, foiling.
No, we don't have to do that, guys. That's the beauty of this right now.
Put the 4 in the 20. You divide both sides by.
You multiply both sides by 1/4, right?
Okay,
Yeah.
I'm not multiplying by 1/4. I'm bringing both sides to the 1/4 power. Now, when I bring 4 to the 1/4, what happens on the left side? It looks terrible right now, but what's going to happen? What is 4 times 1/4? 1. And anything to the 1 power is itself. So so the left side just becomes x minus 3.
And then the other side
Equals
is 21
And it exactly it goes to the 4th root of 21, whatever. Right? I can write it this way, or I can write it to the one that before. Now I'm not done yet because of the x.
plus. It says no, we're not.
It says plus or minus, doesn't it?
It's just like a weird.
Okay, so I'm gonna add 3.
So x equals
So
4
4
Okay.
plus 3.
Now, okay, before we're totally done, all right, let's remember something about this. When we take the square root of a number,
Plus or minus.
thank you. When we take the square root of a number or the even root of any number, we remember that there's 2 possible answers. It's going to be plus or minus the square root of 9. This is also something that I failed to tell you about taking an even root, is that the even root, anytime I take an even root, it could be either plus or minus the final answer. All right? Just like the square root. So what I don't have here is the plus or minus when I take the 4th root. So what is the final answer going to be? It's going to be x equals 3 plus or minus the 4th root of 21. So let's just remember that when we if you do these problems, if you're doing the problems on big ideas, it's going to ask for 2 answers when we take a 4th root, right? It's going to ask for the plus answer and a minus answer. Okay, we're almost done. And I know you guys are almost done too. You guys have been absolutely tremendous. I'm going to move down to the bottom here, and I'm going to see if you guys can't, if we can solve 13, 14, 15, and 16. I know I didn't give you enough space, but let's see if we can do number 15 and 16. They're the more complicated ones, right?
So we don't have to do the example 5.
I'm not going to do that right now.
Okay.
All right, going to save that from you.
We're doing 14, 15.
Let's, how would I do 15?
Times it by 1.
I'm going to write this as x plus 5 equals, I have to take what? Did you say the 1/4 power? So I'm going to take the 4th root of both sides, right? When I take the 4th root of the left side, that leaves me with x plus 5. And then I have the 4th root of 16, right? But what do I need to be in front of, what needs to be in front of the radical?
plus or minus.
Plus or minus.
And that's going to be x.
Plus or minus 2.
So minus 5 equals,
Plus or minus 2.
okay, I'm sorry with that. I subtract 5 from both sides. So I got x equals minus 5 plus or minus, what is 4th root of 16? 2. All right. Question, do I have to do plus or minus for cube root? No,
Only for
Even.
only for evens, like square root. How would I do this next one? Cube, all right, I'm going to take the 3rd root. If I take the 3rd root of the left, what do I get? And you can't simplify it, you're right.
Plus or minus 3.
It's just going to be plus.
1.
Why is it plus with the minus? We can take the cube root of a minus or the cube root of a, for instance, think of this one, right? If I take the, if x is equal to the cube root of negative 27, What is the cube root of negative 27?
Oh, because it's odd, right?
It's negative. It's negative 3, right?
No. Oh yeah.
It's gonna be negative 3. Anytime I take the cube root of a number, I get only one answer. It's only when I do something like this, when I go square root, when I take the square root of 9, all right?
That could be plus or minus.
It could be plus or minus. Why is that?
So when the inside was negative, then it's only plus.
When the inside is, yeah. So it's when, it has to do with whether the root is odd or even. If it's an odd root, the answer, there's only one answer. If it's an even root that you're taking, then there's a possibility of either a negative answer or a positive answer. And we'll get used to this. We're just going to get used to it.
Odd root has one answer.
Correct.
Even have
Even root has a positive or a minus negative answer. Okay? Can you guys, is there any possibility did anyone do number 13 and 14 yet?
13 is 2.
13 is 2, or plus or minus 2, or just 2? It's just 2, right? Because it's a cube root, right? And did anyone find the fifth root of 1024? You multiply both sides by 2 for 14, and you get x to the fifth equals 1024. Is there a fifth root of 1024?
4.
Is it really? Wow. Is it plus or minus or just 4?
4.
All right. So it's to the 1/5 power to the 1/5 power. You're just taking both sides to the 1/5 power. You can put it right in your calculator. Make sure you put the parentheses in, right, Abby? And you're just going to get x equals 4. Nicely done, guys. I think it's time for lunch.
Yeah, actually, that's
Good class.
What's that?
history.
Oh my God, that was a good class. I thought I killed you.
We got a lot done.
Okay, that's all for now. You can start your homework if you have time.
But like, it's like handwritten stuff.
That's all, folks.